All right. In theory, we're live. Sorry about last week. My voice crapped out. Um, like at the, I was feeling it like we did Astronomy Cast on the same day on the Monday, and I was feeling it earlier on in the day, and it was just getting worse and worse, and I didn't want to do any more damage. So I decided at the last minute to call the show. Sorry about that. And I also sort of realized it's not a great way to just communicate. I mean, to just kind of tell everybody that there's a change happening. Anyway, but we're back. I hope you all enjoyed the Starship launch, the double launch. That was amazing. What a day! What a time for a space flight. Just incredible. All right. Well, so hey everyone, welcome to the question show. Your questions, my answers. Wherever you are across my channel, if a question pops into your brain, just write it down. I'll gather them up and I'll answer them here. And of course, I do this show live every Monday at 5 p.m. Pacific time on my YouTube channel. So if you want the best chance of getting your questions answered, including follow-up questions, you'll want to join me live. But still, I'm trying to be active in the chat, in the comments, and gather up questions from all the sources. All right, let's get into this week's questions. All right. Dwayne Duvall asked, does dark matter clump together like normal matter, or does it have a maximum density? No, dark matter seems to clump completely differently than regular matter. And this is one of the things that's really interesting. This is why astronomers call it cold dark matter as opposed to hot dark matter. And that's because from the way they do the observations, dark matter really doesn't seem to clump in the way that regular matter does. And I'm sure you're like wondering, like, we don't even know what dark matter is. We've never even observed it. How do we know whether or not it clumps? And the answer, of course, is this incredible observation of this place called the Bullet Cluster. Like more than a decade ago, astronomers observed this giant galaxy cluster that's really far away called the Bullet Cluster. And the cluster was in the process of merging. And as the and what had actually happened is the merger had happened a long time ago. And so the two groups of galaxies had smashed into each other. And so what you were able to see was, you know that the galaxies are made of stars, and the stars are really far apart. And so you would assume that the stars would kind of mess each other's orbits, but they wouldn't actually bash into each other. So the stars kind of passed through each other as the galaxies moved through. But the gas, it clumped up because the gas is sort of everywhere and the particles are fairly warm and they have a large cross section of gas. Like think about, a balloon. When you inflate a balloon is just gas bumping into each other inside an enclosed space that keeps it inflated. And so the gas in these galaxies actually clumped up together in the middle, even though the galaxies had sort of passed through and you're left with this region where the gas had collided. And through gravitational lensing, astronomers were able to look at the areas around the galaxies themselves and see that in fact the dark matter had moved with the galaxies themselves. So it hadn't collided. Even though the dark matter should have crashed into itself, the dark matter just passed right through itself and moved back out with the galaxies. So what this tells astronomers is that dark matter is some kind of particle with a very small cross section. Means that it doesn't have the ability to bonk into each other. You could inflate a balloon with dark matter and it wouldn't inflate. It wouldn't stay inflated in the same way because the particles aren't colliding with each other. Now, that sounds kind of magic. Isn't the same thing as a particle that doesn't collide into anything the same as, I don't know, nothing? But we have a great example of a particle that doesn't collide with anything very rarely, and that's the neutrino. So, of course, there are nuclear reactions going on in the sun nonstop. 4 million tons of hydrogen is being converted into helium every second. And that process is releasing gamma radiation. Byproduct is helium. But when astronomers did the math, or when physicists did the math for that, they realized there was like a little bit extra that should be there as well. And so they predicted that there was this additional particle called the neutrino. But the particle was really hard to find. They said, if this thing exists, you must have countless billions, trillions of these particles passing through your body at all times. And yet they interact so little that you don't even feel them. And it took bigger and bigger, essentially vats of water for particles to pass through until they finally were able to find an example of a neutrino colliding with a particle, releasing a cascade of other particles, and that told astronomers that in fact this thing, the neutrino, exists. So when you think about dark matter as a particle, as an example, and I always give this example that a neutrino could pass through a light year of lead, of solid lead, and not interact with any of the atoms of the lead. That is how small a cross-section the neutrino has. And so when you think about that idea, dark matter won't clump up in the same way that regular matter will. And there's all kinds of interesting implications of this. Like, I think we've talked about this before, that if you have like a black hole and you have dark matter swirling around a black hole, with regular matter, the matter is kind of bouncing into each other and slowing down its orbital momentum, and it goes into this death spiral around the black hole. But dark matter, because it doesn't have that cross-section, isn't going to be going into the black hole. It's not going to be bouncing into each other and slowing itself down. And so, although particles of dark matter could go into a black hole, they're not going to go in and clump up in the same way. You're not going to get accretion disks in the same way that you do with regular matter. So it does clump, but not like regular matter. It has a very, very small cross-section. Okay. Ollie's asked, are we on the new Sony? No, not yet. I haven't got it set up yet. There's like a bunch of software that I'm having trouble getting configured. We'll get there. All right, this is awesome. Jonathan Allen, when will Starship stop blowing up in Texas? Man, I don't know. Like, starships blowing up is what they do. It would feel like a total, if we were in a world, I wouldn't even know what kind of world we were living in if starships didn't blow up. Every starship so far, really, that's been assembled has exploded unintentionally. They were from pressure, from testing engines, from actual flight tests, and of course landings. Yeah, they just blow up. It's what they do. And of course, I mean, this is it. This is what rapid iteration looks like. And of course, if you go back and look at old-timey footage of NASA and the Soviets testing rockets, they all blew up. I mean, it's just like there's so many hilarious blooper reels of rockets exploding. And of course, we know of much darker times when rockets have exploded with humans on board. So rockets are super incredibly dangerous. And it's hard to appreciate how much danger and how unpredictable and how really at the very limits of movement rocket is, because you're literally taking a payload and you're accelerating it from 0 to 25,000 kilometers an hour in about 10 minutes. It's a phenomenal amount of energy, and the only way to do that is to release, to have a really, really powerful fuel and to release that fuel very quickly in a very explosive way to generate your flight. Now, of course, the funny thing, or the not funny thing anyway, with the starships is they've been landing and then exploding. So every other part of it, the flight, the maneuvers up in the air, and even kind of getting close to the landing part, it's all worked really well. It's just really sticking that landing. And then again, though, you think about it, is this building-sized tower of stainless steel that you're attempting to touch down gently, filled with liquid methane. It's incredibly difficult. And I think we're going to see this more and more. I mean, when you saw that latest landing of SN10, like, it landed, but it was a hard landing. You could see it kind of bounce, and that was enough to rupture whatever was going on inside of it to then make it detonate. And so they're going to have to continue to perfect the technology of make this thing softer and softer in landing, or some other way that the landing legs work. Because I think with the Falcon 9s, the landing legs are carrying a lot of the load as the thing is coming down. I don't think they've come up with the same idea with the Starship, and eventually with the, I know with the Super Heavy, the plan might be to have it land on a crane. So I think this is going to take them a little while. I wouldn't be surprised if we see a couple more of these things explode before they really get it right. And it might be that they're going to have to over-engineer the landing. That, you know, one of the advantages of Starship with the Raptor engines is that it can hover, while say the Falcon 9s, they have to do this thing called a hover slam. So they, as they come down, they can either go up or be turned off. And so they have to fire the rocket at the last second to cancel out the downward velocity so that it essentially equals zero at the moment they hit the ground. But the Starship with the Raptor engines could get closer to the ground, hover, get a little closer to the ground, hover, and then slowly touch down. And maybe they're going to have to spend their time working more on really perfecting and figuring out what are the forces that it takes to be able to land this thing, and then teach that to the artificial intelligence that's running the landing so that it can keep its tolerances even closer. Because, you know, we've seen now 3 hard landings. I suspect we're going to see more of them until this gets sorted out. So I would not, at this point, I would not be surprised if the next one explodes as well. But I would be pleasantly surprised if it didn't. I want to get, you know, for me with Starship, the big question, the thing that I really want to get to is, when do we see orbital reentry? That's the key, is the orbital reentry. Can a Starship make it back through the atmosphere and land? Every other part of it seems totally feasible to me. It's that orbital reentry that I'm super nervous about, and I'm really excited. If we see that work, then everything changes. If we don't see it work, if we see them, you know, obliterate Starship after Starship, then they're going to have to go back and make more fundamental changes in the way this whole system works. Okay. Horizon Brave. Fraser, have you heard of the Stellina telescope that you can buy? They sell it for 4K, but it's supposed to be like an all-in-one imaging device. Have you seen it? Not only have I seen a Stellina, I've actually played with one. They sent me a demo unit about 1.5 years ago, and I was able to spend about 3 weeks with it. It's amazing. You take this thing, it kind of looks like the portal gun. You set it up, you have an app on your phone, you turn on the telescope with your phone. It figures out where it is on planet Earth. It orients itself. It takes a picture of the sky to figure out what its orientation is compared to the sky. So now it's literally polar aligned itself. And then you just give it targets. You say, give me a picture of this galaxy, give me a picture of that nebula. And it does it. And it uses fairly modern astrophotography methods of directing at some target and building up an image over time. You know, the longer it sort of takes a picture and then takes another picture and takes another picture and then averages out the 3 pictures and throws out the bad data and just gets better and better and better. And it is as simple as it looks in the pictures and in the videos. Literally, you set it up and you're starting to take pictures. And even in light polluted skies. I mean, you know, when you look through one of the biggest telescopes that you can get your hands on at the Andromeda Galaxy or the Orion Nebula, they all just look like fuzzy bits. It's only when you actually switch to astrophotography that things really look good. And so this is a great way to do entry into astrophotography. Now, that all said, it's $4,000. $4,000, you can buy a really nice telescope mount, a really nice telescope, a really good camera, and do astrophotography that will blow the Stellina away. But it's a total pain. Like, I've never experienced a telescope that's so easy to use as the Stellina. It is wonderful. And so I think, if you've got like a ton of money and you just want to start taking pictures of the night sky, I would get one, right? If you're rich. If you're not rich and you want to get into astrophotography, I would start with a much cheaper setup and learn kind of the hard way and like treat it like a serious hobby and get to know it. because it's the future. That they have cracked it, and there's others as well. Unistellar, and I'm sure there's going to be a million of them coming out shortly. Just this idea that polar aligning your telescope for a night of observing is misery that absolutely takes away from the experience of doing astronomy. It is the worst part of doing astronomy. It makes me not want to get my telescope out when I see interesting things in the night sky, because I'm like, oh, I've got to align it. Let's just use the binoculars instead. Let's just use the Dobsonian instead. So yeah, no, I think it will be a revolution, and you're going to need to see that technology brought into other telescopes. Because the thing that I want to see is that amazing tracking ability matched with a really good telescope. That if you get those two together, I mean, it's not that it's not a good telescope, right? It's a really nice, I think it's like an 80 millimeter refractor with a pretty good camera, but you're not going to be able to upgrade the telescope. You're not going to be able to upgrade the camera. So you're sort of stuck with what you get. While with a regular telescope, you're like, I want to get a better lens, and I want to get a better camera, as the new upgrades just keep coming. So I would say if you're super rich, definitely buy one. Like boom, you're doing astronomy, you're king of the world. If you aren't rich, then I would hold off and wait until that technology gets more commoditized. And even though they've got a cheaper version coming out as well. So, but yeah, I does it work? 100%. What they say it does, it absolutely does it. I don't even know what Dear Moon is. Okay, I'll do this one here. Pacer, do you agree with Avi Loeb that there is a conservative bias in mainstream astronomy about life elsewhere in the universe? Maybe. All right. So let me just sort of explain what I think Avi Loeb's position is. And again, I'm still trying to sort of coordinate an interview again with him, so stay tuned for that. But he feels that extraterrestrial life is like one of the most important questions that you can ask, and weirdly, the mainstream scientific community is not that interested in funding it, not that interested in investigating it, and I would say that I would agree. And I had this conversation with Dr. Jason Wright a couple of years ago, and he was like we're okay looking for dumb life. Why aren't we allowed to look for smart life, right? Like, why not? And I think that because extraterrestrial, like if we found evidence of extraterrestrial intelligence, it would be the most profound discovery in the history of humanity. We are not alone in the universe. There are other minds out there as intelligent or more intelligent than us, with civilizations. Like that means a lot to who we are, and potentially we could communicate and share knowledge. Potentially they could be a threat in the future. So it's important to have an answer to this question. But I also understand why the mainstream science community isn't interested in looking into this. And the answer is just because it's really hard to gather any firm evidence. You can set up a radio telescope and you can scan the night sky for evidence of aliens, and that's being done. It's definitely underfunded. It could be done way better than it's being done right now. But apart from that, we don't have a lot of ways that we can search for extraterrestrial civilizations. There's a couple of stories that we're working on right now. One, just this idea of technosignatures. Like what's every way that you could search for intelligent civilizations out there? Not just their signals, but let's look for their pollution, and let's look for their light pollution on their planets. And so there's a lot of really clever ideas that are starting to come out, and it would be great to see some of those applied. But I think that you have to balance that with being able to get funding for your projects. And it's sort of, there's a lot of biases against people doing those kinds of searches. And I think that for a lot of astronomers, a lot of researchers, they don't want to put their neck out. They don't want to say, okay, what are you doing? I'm searching for aliens. And you're like, okay, funding canceled. And so I think that that's sort of where it all comes to. But I also feel like that's changing. I mean, you have people like Jill Tarter, who, they made the movie Contact. She's an inspiration for all of us. And there's a Seth Shostak, and then a lot of others who are, and then it's a new generation, Kipping, Jason Wright, who are still, and Avi Loeb, who are like, they're making searching for intelligent civilizations cool again. They're making it okay to talk about these ideas, to ask these questions, and to think of practical ways that we could get an answer to this question. And so I think the time is right. I've been advocating for this for years. Not that I have any pull, but still. So yeah, I think in the end I do agree that there's a bias against spending money looking for an answer, because people don't feel like the answer is easy to get, and they don't want to spend money on something that is going to be really hard to get an answer for. I think that's where it stems from. I don't believe that, everyone's like, oh, we're just not ready for the answer. No, we're totally ready. I'm ready. 100% ready. Tell me, let me know whether or not there's alien life out there. I want to know. So I don't think that's the reason. Do I think that there's like a bias? No. I mean, I think you ask any astronomer, pretty much every astronomer, and say, is there life in the universe? Most of them will say yes. Most of them will say, I believe that there is. Like, it seems impossible to me that there isn't. And so it's just, how do you practically look for it? How do you spend money on what instruments, on what telescopes, to gain some kind of evidence that helps you get at an answer on whether or not we're alone in the universe? That's the tricky part. And that's the part that I think only recently have the telescopes and the missions gotten to the point where they can actually give us definitive answers on these questions. Let's see. Oh, that's a good question. All right. Zach Perry, what do you think the universe would be like in various eras after the Stelliferous era? Just a lot of black holes. So that era, so what you're talking about is the far, far future. In the when you think about the universe today, we have all of the stars that are in the galaxies, but we're actually past the peak star formation. That was about 4 billion years ago. Now, actually, the universe is starting to wind down in terms of star formation. And it's going to still keep going, but you're going to have less and less stars forming every year in all the galaxies, until all the galaxies are these aging elliptical galaxies filled with red stars. And then one by one, those stars will wink out as they turn into white dwarfs, neutron stars, black holes. The neutron stars, black holes merge with each other. You're going to have planets, rogue planets, that are just drifting in the cosmos, completely devoid of any kind of heat. They're going to cool down to the background temperature of the universe. And so in the far, far future, what you're going to end up with is black holes and everything that didn't go into a black hole. And that's it. So, if you have a rogue planet that didn't end up in the clutches of a black hole and was able to escape out into, it's just going to drift forever. Everything else is either going to go into a black hole or just be all alone. Now, way beyond that, you've got to ask yourself, like, do protons decay? If protons actually decay, and we don't really know yet, then you can imagine all of the actual material that didn't go into black holes is just going to evaporate into various particles. Then the black holes themselves will evaporate again. And so in the end, beyond the black holes, beyond matter, you're just going to have just individual particles spread. And of course, the universe is going to be continuing to expanding, and dark energy is going to be accelerating the expansion of the universe. And so you'll end up with just vast emptiness with particles, energy that have wavelengths that are light years across more. and there will be no more useful work that can be done in the universe. So that's what the future looks like. But really, when the last red dwarf goes out, say 10 trillion years from now, that's going to be the last time the universe will be productive, that there will be significant energy that you can use. Now, people have proposed like really exotic ideas that you could huddle up around a black hole and you could drop matter into a black hole and extract the energy. And of course, because you're close to a black hole, you're going to be experiencing time dilation, where actually the background radiation of the universe will blue shift, so it'll be hotter, warmer. These are all great ideas, and so I'm sure a very intelligent, very advanced civilizations will be able to figure out clever hacks to be able to live longer into the future of the universe. But even still, the heat death is the heat death. Can't avoid it in the end. But it's a great question. I love to think about it. All right. Trey Harmon asks, hey Fraser, can you tell us what things factor into the determination of the von Karman line? Is the edge of space purely atmospheric, or is there more to it? The von Karman line is really just a subjective number. There's no real specific place where Earth ends and space begins. At the lower altitudes, of course, the atmosphere is very thick. You get up to the stratosphere and above. And eventually, when you're up around 100 kilometers, there's literally, like almost no atmosphere. But there is an atmosphere. And in fact, the atmosphere of the Earth extends at least 10,000 kilometers above the surface of the Earth. And it's thought that it goes all the way out to the moon. And of course, the size of the Earth's atmosphere depends entirely on the strength of the solar wind. The solar wind buffets the Earth's atmosphere, pushing it around. So where the edge of the atmosphere is depends on the distance to the moon and the power of the solar wind. And so it's really very subjective about where it really stands. And so people will come up with different definitions of what it is. So, yep. There's no other way to sort of describe the edge of space. I mean, when you think about the gravity of the Earth extends all the way to the edge of the observable universe. You could be billions of light years away from the Earth, and as long as it's been since the Earth has formed, you will be experiencing gravity, not very much, from the Earth. Same thing with the magnetic field. You're going to experience the Earth's magnetosphere even when you're halfway across the galaxy. NorCal Pacific. You said you're currently watching Babylon 5. Would you recommend Babylon 5 over DS9? Why choose? Watch them both. If you had to take one away from me, I would choose to watch Babylon 5. I think Babylon 5 is better than DS9. That's my opinion. And again, we've now finished the first season. We're into the second season, the part where it gets good. And the first season holds up so much. I know I talked about this last time, but it's so good. The makeup is amazing. The computer graphics for the time, they did it on an Amiga. It's incredible. And they've upscaled the graphics. So in many cases now with the season 2, they look really good. And the storylines, they really figured out this idea of telling a long, overarching story with a beginning, a middle, and an end, with characters that change over time, with crises that grow and get resolved. It's wonderful. I'm really enjoying going back through it. And it was funny because last night we were watching it, and normally, with this first season, Carla's like, yeah, I know it's going to get better, but I'll just take just one. And last night I think she was like, no, we'll do another one. Okay, we watched 3 episodes last night, so we're back in it. We're watching. It's good. Watch them both. But if you haven't watched DS9, watch it. And if you haven't watched Babylon 5, watch it. All right. Zappan. Dear Moon. Okay. So Dear Moon. All right. Dear Moon. let me do this again here. Zapfan. Dear Moon, the Japanese guy who's funding Starship to take a trip around the moon with a bunch of invited artists was the question if you wanted to go. So I'm going to change this question. All right. Zapfan. The Japanese guy is funding Starship to take a trip around the moon with a bunch of inviting artists. Would you want to go? No way. Not a chance. I do not want to fly on a Starship around the moon or Falcon 9, whatever. No way. I like Earth. I've mentioned this in the past. Like, I'll fly to space after Elon Musk's mother does and return safely. It's, I mentioned at the beginning of the show just how incredibly dangerous and just risky a flight into space is. I mean, you think like practically, like what would it be? You'd be on the rocket. It would be terrifying. You'd be in space. It'd be cool. Then it would be boring while you flew to the moon, or you'd be floating around. You go over the moon. That would be amazing. You'd be looking out the window, and then you come back, and then you'd have the terrifying return to Earth. So, if I could fly to space and it would be safe, I would do it. If I could go to the moon and bounce around and go on a holiday, sign me up. As long as it's safe. But right now, spaceflight is an incredibly risky endeavor that I think every time a human being goes to space, gets in a rocket ship, you've got to have a really serious conversation about whether or not this is the right thing to do. I don't think we're ready for wide-scale space tourism yet. We saw the price with the space shuttle, 2 space shuttles destroyed, 14 people. Like, what's going to happen when 100 people die because a Starship explodes on the launch pad? And I understand there's plenty of people out there willing to take the risk, but not me. I enjoy life too much. And I just think that we need more time for this technology to become trivialized. Would I have been a barnstormer in the 1920s? No way. I would have not gotten on an airplane. Will I get on an airplane today? Absolutely. No question. It doesn't cause me one moment's fear to get on an airplane today. So space flight, hopefully, will follow a similar curve where we start out and it's terrifying, and then we get to a point where it's safe. And we're not there yet. And so I don't think it's time to have a conversation about space tourism yet, in my opinion. But it's a free world. And so there's rocket companies willing to build rockets that will carry people to space, and people willing to pay money to go to space. And now KISS. But I will not be a part of it. I will watch from afar and report on what happens. Jens Oddvar. What would happen if a black hole and a white hole crash? I know white holes are probably not real. The white hole would disappear because anything goes into a white hole, it causes the white hole to collapse. So mathematically, even though white holes probably don't exist, they exist as a mathematical sort of, if you reverse some numbers on the black hole mathematics, you get a white hole. Doesn't mean they're real, just means that you can reverse numbers on them. But the math also predicts that if there's anything, even a single photon, then the white hole will collapse, especially if there's a black hole. Let's see. People always want to know what I think of television. All right. Raphael Dominichini. And Battlestar Galactica, what do you think? Oh, I have such a love-hate relationship with Battlestar Galactica. The first parts of Battlestar Galactica were amazing. The end is so awful that it undid all of my fondness for the show. I won't watch it again. Carla just rewatched them, and she was like, yeah, these are really good. And I'm like, oh, I don't remember them being this good, but they're so good. I'm like, I know. And that's what makes the ending so tragic, so bad, so heartbreaking. So yeah. Oh, interesting question. All right. But I don't know the answer, so I'm not going to answer it. Sorry, Fugal Creations, you asked if a neutron star could have an event horizon just beneath the surface. That's a great question. No, it wouldn't. It's interesting, though. Because if it had an event horizon, it would suck itself inside, out. All right. All right. Void sector. What's the current status of James Webb Space Telescope? Oh, okay. First, let me say James Webb is absolutely going to launch October 31st, 2021. Look at the date today, March 8th. We are 8 months away from launch. It's going to happen. No more delays. Now, that's just me hopeful, wishful thinking. But to be honest, I haven't heard of any other problems in the development of James Webb. They just, like a couple of days ago, did another full test. They sort of went through the entire process, unfurled it. They, did a full integration test. And so at this point, it's ready to go. The rocket's ready to fly. So I haven't heard of any other issues that are going to hold up the flight of James Webb at this point. Of course, last minute problems can happen, but I can't think of anything that's currently an issue for it. That said, I mean, it's such a complicated telescope. So much can go wrong once it actually gets out into space. If any one of the hundreds of actuators fails to deploy, then it won't be able to put out its sun shield properly. It won't be able to deploy its main mirror. I mean, it's just every little piece of this has got to go right. So here's hoping. All right. Phil DeShane. What are the practical implications of Venus not having a moon? How would we think of it differently if it did have a moon? So, I mean, we don't know if Venus had a moon in the past and it lost it. I mean, in the way that, say, Mars is going to be eating one of Phobos in the next, say, 50 million years or so. And it might be that Venus used to have a moon. Venus had some kind of large impact, created a moon like the Earth, but the moon was too close, and so it spiraled inward and crashed back into Venus. Definitely Venus's funny orbit, rotation, could be explained by it having a large moon in the past, or at least that it was hit by a large object in the past. Because, of course, Venus takes, I forget the number, 225-ish days to orbit, to rotate. And it goes backwards. But it takes, anyway, it rotates backwards, and it rotates very slowly. And like, you could walk on Venus and you could outpace the sun. You could never see the sunrise if you just walked on Venus. You could outrun it. And so the fact that it orbits, that rotates backwards from all the other planets in the solar system, that's weird. What that means is that it was flipped over entirely. And so for it to be flipped over entirely means it had some kind of catastrophic collision. Or by not having a large moon to keep it balanced, it just flipped over. And so it might very well be that the fact that Venus is rotating backwards is the explanation that it used to have a moon, that it never had a moon, and that by never having a moon, it couldn't keep itself stable, and it just wobbled upside down on its axis. So we've reported many times on like, if Venus didn't have a moon, it would explain its weird rotation. And then we also have, like, if one big impact could have flipped Venus over billions of years ago. And so astronomers, this is an open question in planetary science, and astronomers are absolutely running their models, trying to figure this out over and over and over again. And we keep covering it with each incremental discovery on this. I hope someday we'll find some kind of conclusive evidence. So if it did have a moon, that'd be interesting. I mean, a moon would be great. Having a moon around a planet is a really nice base of operations. And it's a way to learn. Like for example, if we had a moon orbiting Venus, then we could explore the moon, and that would tell us a tremendous amount about Venus, while Venus itself is so awful to try and explore. So it might actually be a lot more practical to study Venus. We're starting to think that Phobos and Deimos are actually pieces of Mars that were kicked out during a giant asteroid impact. And so by landing on Phobos and Deimos, which is relatively easy compared to actually going to Mars, you can learn a tremendous amount about Mars, what the early material under the surface might have been like. So that would be amazing if Venus had a moon. It's really now getting sad that Venus doesn't have a moon. So that'd be cool. A.V. Scott. All right. A.V. Scott and Flower. Fraser, do you have a solution for Starship's legs? Seems like a big obstacle for an even bigger 18-meter Starship 2.0. Well, let's solve one problem at a time. If you look at the video of Starship's landing, just as it was coming down, and Scott Manley did an amazing sort of coverage of this. Just as it was coming down, you could see that a couple of its legs weren't locked in place. They were sort of rocking back and forth underneath. And so that sounds like a fairly simple mechanical problem to fix. But how do you handle all of that weight? This office tower, coming down on steel legs. Clearly and something that's lightweight that you can actually carry. I actually think the idea of catching these things is pretty clever. I would not be surprised if they consider the same idea for Starship as they're considering with the Super Heavy. So with the Super Heavy, the idea right now is that it won't have any legs at all, that it'll land and be caught by this big crane that will support the weight on the grid fins on the top. And then they'll gently put it back down, stack it back up, and fly it again. And it might very well be that they can't sort out how to land this thing on some kind of leg system that won't buckle, that won't just take too much damage and be too heavy. I mean, you could give it landing legs as beefy as the Falcon 9's landing legs, but then you're just carrying so much weight into space. So, in Elon Musk's famous words, no part is the best part. The best part is no part. Maybe the best part of Starship is having no landing legs, and instead you've got some, if they can really stick the landing, then maybe you've just got some kind of system that the crane can catch and hold it in place as it's coming down. Or again, if this thing could hover, imagine the thing hovers close to the ground and then just sort of moves sideways into some kind of dock and it gets captured. So I think that there's, the fact that it can hover gives them a lot of opportunities to explore other ideas. Maybe they're going to have to end up landing this thing in water. There's tons and tons of ideas. They haven't explored them all. And I think that's the thing that I really wish people would have more patience for, is that they see iterating and problems as failure. But everyone knows that when you try to do something hard, you're going to experience problem after problem after problem. And the fact that they're iterating this out in public just is a demonstration that they're willing to take all of this criticism on the chin and just keep going. And so it may very well be. I mean, they originally were going to build Starship out of carbon fiber, and now they're building it out of steel. Like, they're going to keep changing until they figure out something that works. And it might be that landing this thing on titanium legs just isn't going to do the trick. And they got to come up with a new idea. And then it's back to the drawing board, and then they'll come back with some new idea. It's fascinating to watch this progress, and it sort of, it goes a long way to sort of showing how difficult rocket flight is and what it takes to solve a problem that's hard, that you're gonna fail a lot, and you just keep going. I hope they don't run out of money while they keep going. But, Starlink will pay for it. Starlink will pay for everything. Starlink is going to make so much money. Oh. Mitch Harpino. When we go back to the moon, is there a foolproof plan to prove that all the moon landing is a hoax, the moon landing is fake, morons, that yes, we have landed on the moon? No. How do you convince a person who doesn't believe in evidence? So what's the evidence? You can't. It's not possible. So the path is the moon, the moon hoaxers, the moon landing deniers. They can just go over there and they can talk to each other in their own safe spaces and enjoy their company with each other. And the rest of us who are into space exploration and space flight and the current progress of the various things that are going on can hang out with each other and talk about the things and consider the future and report the science and the discovery and the challenges and the things that are actually happening. I don't think we need to pander to people who aren't really interested in having a genuine conversation, an open conversation. It's not my job. It's not NASA's job. NASA's busy launching rockets. And I think that the less time we spend talking about these ideas, the better. I actually spend very little time on my channel addressing these kinds of issues because I don't care what a person thinks about whether we did or didn't land on the moon. I literally do not care. And so I don't think you care. If you are like a moon hoaxer, this isn't the place for you. There's lots of places. It's a great big internet out there. Go find a community and have a chat with your buddies about the things that you don't believe are true as much as you like. And if you want to have a conversation here and be a jerk about it, we just ban you because, this is my house. You can have conversations you want in your house. So no, there's no evidence that will ever convince them that we're landing on the moon. They didn't believe that Elon Musk was launching Starman in his Tesla. Thought that was a hoax. Everything's a hoax. Everyone's in on it all the time. It's a giant conspiracy. So. Matt John 02. What are your thoughts on Star Trek Enterprise? In my opinion, NX-01 minus the warp drive and artificial gravity could be built today if we wanted it to. I don't know. No, the things like that can't be built. Like, what's the engine, right? What is the fuel source? What is the propellant that's needed? When you think about the space missions that we send today, they have all the propellant is required just to get them off of the Earth's gravity well. And then they fly through space and they arrive at their target destination and they use the rest of their propellant to be able to go into orbit around that destination. Maybe they have a little tiny bit of propellant left to be able to make some minute course correction changes to get into a different orbit. And then they're pretty much out of propellant and they have to eventually be crashed into the planet. That is the state. That is the state of the art of space flight for humanity today. Now, maybe when Starship flies and they're able to perfect everything and they're able to get orbital refueling, then we'll see rockets with much more expanded capabilities, being able to perform more complicated missions. But you always are just like ticking down the time for the amount of propellant that you have on board. But infrastructure, like, again, we are pre-car in terms of spaceflight right now. But imagine there was like no place to fill up your car. Like your car could take you as far as you had gas in the tank, which was not very much. But now there's gas stations. And so you can stop at one gas station and refill and go to another gas station and refill and so on. So it's that infrastructure that we're going to require. We're going to require refueling at various points across the solar system where starships can go and refuel and fill up with more propellant. And there's going to be factories on asteroids and comets that are extracting resources so that people can be refueled, but that's going to be very complicated and require very, robots and a lot of technology and coordination and all that kind of stuff. So I think we are at least 100 years away from, which is not long. I mean, we think like, what's 100 years? It's not long. Not today. I don't think we have any value today to build something like that because there just isn't that infrastructure yet and what are you going to do with it? Are you going to have humans on board and fly from world to world across the solar system? Just like there's not targets to go, there's not capabilities to have, there's not ways to refuel, like we just don't have the infrastructure. But that's going to come in bits and pieces, in big and small, and over the next, say, few hundreds of years, that infrastructure is going to get built up. And then, you will be able to hop in you're going to catch a shuttle from the surface of the Earth to orbit. You're going to get on your Trans-Mars shuttle and spend a couple of months on the way out to Mars, and then you'll be able to land on Mars, and there will be shuttles, ferries going back from Mars to Earth, and there's going to be other stuff as well. So I think, hundreds of years. But I don't know whether like something like the Enterprise. There's a lot of metal. It's very heavy looking. Like mass is the enemy in space. And so what you really want is something that's very lightweight. You want something that's made of just a tiny little bit of aluminum and thin aluminum foil, protecting you and the vacuum of space, because you want to use the minimum amount of mass to move around. So science fiction has prepared us poorly for what the future of space exploration is going to look like. Don't get me wrong, I love Star Trek and Babylon 5 and The Expanse. All we need is an engine that's millions of times more efficient than the best engine that's ever been developed today. That'd be great. Samurai Hash. Fraser, what do you think of crowd-funded science missions, such as to Titan or Ganymede or Venus? I don't think that crowds could fund those kinds of missions. Like the prices of a mission to Venus or a price of a mission to Ganymede or Titan is just so much money. Like, let's take the cheapest possible version. Like a mission to Venus. You launch on a Falcon 9. Okay, you're paying $60 million for your launch on your Falcon 9. Let's say the probe would cost you another $50 million. And you're doing that on a shoestring. That would be tough to crowdfund a $150 million mission. Now, obviously, that's like less than the budget of a single movie, but movies make a lot of money, and there is no financial incentive to do it. Right? There's no money made when your mission arrives at Venus or when your mission arrives at Titan or Ganymede. You don't get any profit from it, and so it's just money that's just lit on fire and sent into space. I think that there is an opening, though, for CubeSats, fairly small missions, things attached to other larger missions that could be crowdfunded. And I think that's where we'll see this start to happen. Wouldn't it be great if there was a space telescope that was freely available by everyone to look through, to just like, I want to control the space telescope for a couple of hours or a couple of seconds and take a bunch of pictures of space and look around. Wouldn't that be cool? So I think that we're going to see those kinds of ideas first, or even like ideas for Earth observation or Earth communication or things like that. Let's start there. And then like there was like there was an idea that I had a couple of years ago, and I don't know if anyone's ever really done the same thing yet, which was I wanted to crowdfund a telescope or a space camera that would just fly around the Earth and just have a view of the Earth that it was constantly streaming, and so you could just go and switch to the channel, and you'd have this nice high def version of just the Earth, looking like you were in orbit all the time, and it would just be like cool, and you could spot landmarks. And I tried to figure out what it would take, and it was at that time it was incredibly expensive, and there was no way to really send your data back home. Now with Starlink, now we're talking. Now there is a global network of of satellites that could communicate, and you could launch a CubeSat that was a camera showing the Earth that could communicate. So maybe I'll see if that's a possibility. Now I'm thinking. But anyway, apart from that, I can't think of ideas that we could just reasonably crowdfund to raise that kind of money. It's a lot of money. Millions, billions of dollars. It's hard to wrap your head around how much money that is. But let's start small. Let's build a telescope that will, a space telescope, that kind of thing. Simon Farmer, will Earthers ban spacers from their online games because their ping sucks? Yeah. I'm going to answer this one. All right. Okay. Simon Farmer, will Earthers ban spacers from their online games because their ping sucks? Yeah, the ping times to go to the moon will be, say, 2 seconds. So, when we measure ping times in online games in milliseconds, a 2 second ping time, a 2000, is that right? 2000 millisecond ping time is bad. Unacceptable. And of course, if someone's on Mars and you're trying to play an online game with them and you're having to wait 20 minutes for every response, I mean, no scope. You got them. The satellites, the satellite things like Starlink are probably going to have faster ping times than fiber optics. It's kind of amazing that once these things get fully operational and they're communicating peer to peer, not communicating back down to ground, once they're linking up and sending their messages, it's actually faster to communicate through space than it is to communicate by ground. And so people who have satellite internet will actually have the advantage in online games, which is kind of amazing. All right, do one more question and then we'll go. All right. Mr. Mann, if gravity moves at the speed of light, how do black holes still have gravity? Gravity is not a force that is sucking things in. Gravity is a distortion of space-time. And so the more mass that you have, the more you distort space-time. And black holes have the most mass concentrated to the smallest amount, and so they distort the most space-time. So it's not about it's true that if a black hole just appeared, then you would have to take time for the gravity to reach you. But that's just the way forces are communicated in the universe. That light, magnetism, gravity, they all move at the speed of light. They all communicate their existence at the speed of light. But still, a black hole just is a distortion of space-time. And that's what causes things to go in orbit around them. Just in the same way that the moon is orbiting around the Earth, not because there's some kind of gravitational pull, but that the Earth is distorting space-time so that the moon thinks it's going in a straight line, even though it's actually going in a circle or in an ellipse around the Earth, which is kind of amazing. All right. We've reached the end of our hour. Thank you, everyone, for taking the time to hang out with me today. We've got a cool interview coming up on Wednesday. I'm going to put it into the queue shortly, all about an interceptor sample return from an interstellar object, an idea for a mission. So this is one of the new NIAC missions. I've got a whole series of NIAC interviews coming up with different technologies, building concrete pads out of lunar regolith, extracting water and metal out of asteroid material, and building an interceptor to catch an interstellar object. So stay tuned for these various. And that cool plasma drive. We're setting up an interview with her as well. So lots of really cool ideas coming up. Of course, if you want to get really cool space news every week, like if you are, you want to keep the conversation going, highly recommend that you sign up for my weekly email newsletter. This is a thing I write every Friday, and I'm sure a lot of the people that are in the chat right now can agree that it is a monstrous, comprehensive document all about all the really interesting space and astronomy events of the entire week. I leave nothing out. Every single new space discovery I cover it in this newsletter. It's totally free. There's no advertisements. I write it myself. It comes out every Friday. Sometimes it's early Saturday, depending on how busy I was on the Friday. But you can go to universetoday.com/newsletter and sign up. And then the other thing that I do is I put all of the work that I do and make it into an audio podcast, the Universe Today podcast. Both the live shows that we do, the interviews, but I also throw a lot of other interesting Easter eggs. Anytime someone wants to interview me, I will ask if I can put the audio of that interview into the podcast feed as well. So there's actually a really interesting interview with me and Simon Dan just recently put into the podcast. So if you're into podcasts, and you should be, because podcasts are like the most convenient way to get your space news or anything, go just do a search for the Universe Today podcast, iTunes, wherever you get your podcasts. And I'll put links to all the stuff in the show notes. All right. Thank you, everyone. And we'll see you all next week. All right. I will end the stream. All right. Thanks, everybody. We'll see you later.